Do I need to make that larger?
A little bit larger would be nice.
How's that?
All right, you're live, so go ahead.
All right. Thanks. Okay. I don't know. I suppose some people will come in. If you don't have TCP dump installed on your machine, please do that while I'm chatting, because that's part of the labs that we'll do. We try and have an interactive meeting, even in virtually. So this is DNS part 2, where we're going to talk about. Oh, by the way, I will paste this into the chat if you want to follow or go or jump ahead. That's fine. Last month we talked about sort of how DNS worked, and Greg did a fine job of explaining recursive DNS and so forth. This month I wanted to talk more about from the host or from your laptop, and how does it acquire a DNS server name? Because when you're getting on the internet, you really need 2 things. You need an IP address, even if it's a private address. Somewhere along the line, it's going to get natted to a real IP address, one that can be routed on the internet, and allow you to transfer packets. And then the second thing you need is a DNS server to look up names for you, because humans remember names, not IP addresses. And especially when you get to IPv6, you will want a DNS server. So what is DNS? Well, it's a globally distributed resilient database, because it comes out of the DARPA days where they didn't want to have a single point of failure. So rather than just have a single DNS server out there on the internet, there are, I believe, 12 root server systems. And there are actually more than each root server system is actually a collection of servers. So how do we get DNS? How does a host get the DNS server? Because if you don't have the server, and that is an IP address, if you don't have the server's IP address, you can't look up names. So how do we get that address of the server? Well, we get it through DHCP, Dynamic Host Control Configuration Protocol, which is kind of what everything in v4 does these days. If we're using v6, we can get it through the router advertisement. There's also a thing, part of DNS, not only the IP address of the DNS server, but a thing called a DNS search list. So if you're ever working for an enterprise, enterprise might be example.com. And so if they put example.com into the DNS search list, then you don't have to type example.com every time when you're looking for a name. And we'll cover this more in detail. Captive portals is another thing that uses DNS. And we'll talk a little bit about how those work with both v4 and v6. And then where is the DNS resolved? Greg talked about recursive DNS and how your first DNS server that your laptop is talking to probably doesn't know the answers, because it's probably a caching server. So who's actually answering that question for you when you look up www.example.com? And if you're using DNS over HTTPS or DO, which always makes me think of The Simpsons, where's that DNS being resolved? So we'll talk a little bit more about that. And we'll talk about using DNS in the small office, home office, rather than using IP addresses of your file server in the basement or whatever. And is it possible to use local DNS? As I said, with IPv6, DNS is going to be your friend, and use DOH. So that's what I'm going to cover in this presentation. Anyone have any questions about that? Okay, moving along. What did I just do? I just clicked to the wrong window. Okay. So let's talk about sort of the first one. Where does the address or addresses, because you can have multiple DNS servers that your host knows about, where does that come from? Well, in the 1990s, after we got tired of statically defining IP addresses and gateway addresses and DNS addresses on every host, they invented a thing called DHCP for IPv4. And pretty much, unless you're configuring a server, that's how machines get their IP address. And there's an option in the DHCP reply that will give you the DNS server IP address, or give you multiple DNS server IP addresses. And if you want to look at what all the different options that you can use for DHCP, that you can click on that link, the blue link of options. In 2003, so about 5 years after IPv6 was standardized, they implemented DHCPv6 for IPv6. And the reason it was later is because when IPv6 was standardized, DHCP v4 was a very new thing, and they weren't sure that was the way to go. There might be a different way to get IP addresses. So IPv6 has a different way of doing it that's from the beginning, 1998, which is the next section. But let's talk about DHCPv6. So DHCPv6 works very similarly to v4, similar in the sense that there's a request made, and there are responses that come back, and they have option numbers. Unfortunately, the option numbers are different from v4. And if you click on that, you'll see that those numbers are different. Any questions about those two protocols? Okay, let's move on to router advertisements. So as I mentioned, when IPv6 was standardized in 1998, they used a different method to get an IP address, a thing called stateless auto address configuration, which is a very clever idea of basically not having to talk to a server and getting a global routable IP address. But they didn't include DNS information. Not sure what they were thinking and how you would get your DNS information, since earlier we already talked about, in order to get on the internet, you really need an IP address and the IP address of a DNS server. But they finally came to their senses, and that was added in 2007, and it's been revised a couple of times about how the router advertisement will carry the DNS server. It also can carry the DNS search list, but we'll come to that. So the problem is, I've just stated 3 different protocols that you can get DNS information from. Which one do you believe? Which one, what happens when they're not all the same? Well, they won't be the same. For example, your v4 address for your DNS server will not be, DHCPv6 will not give you a v4 address for DNS. It'll give you a v6 address. So right there, it's different, and the option number is different. So if you get different DNS servers, how do you resolve them? How do you resolve which one takes priority over the other? And so I created a little chart. If you look at the 2 RFCs that I have mentioned there, they're the folks at the IETF, or the ones who write the RFCs. The RFCs are how the internet works. Essentially, they're the rules of how the internet should work. And it basically says that if you get a DNS server via DHCP, you should prefer that over Slack or over the router advertisement. But it doesn't really say, if you get an address over DHCPv4 and you get an address over DHCPv6, which one do you prefer? So what I did is I did a little bit of homework and try and figure out how the different operating systems actually do this preference when there are multiple sources of DNS servers. And this is the little table that I created, where essentially both Windows, Mac, and Linux being systemd, Linux, prefer most heavily, they prefer the v4 address from DHCP v4. If that's not available, if your DHCP server doesn't give it to you, or you're not doing DHCP for some reason, but the machine is doing DHCP v6, then it will use the DHCP v6 server. And then in compliance with RFC 80106, if there is no DHCP on being served, either v4 or v6, then it will use the router advertisement DNS information. Unless you come to BSD or Android, which do not support DHCP v6 at this point in time. So if you're creating a network and you're going to have Android, or I also include Chrome OS because it operates very similarly from the point of DNS, you're going to need to either run dual stack and run DHCP v4, or you're going to have to rely on just the RAs. But there's no clear RFC that says you should prefer one or the other. In fact, I have a bug open against systemd on this right now. And they're arguing with me why they need to change it. So the problem has a different solution, or the IETF has taken a different solution to how to solve this ordering problem. Because unlike Happy Eyeballs, anybody not know what Happy Eyeballs is? Okay. Unlike Happy Eyeballs, DNS is not requested over v4 and v6 simultaneously, like we do on a web browser. There is an order to the number of IP addresses for DNS servers, and the way DNS has worked for ages and continues to work is that it tries the first one. And if the first one doesn't give you an answer in whatever the timeout is for that operating system, 20 to 60 seconds, then it will go to the second one. And if it doesn't get an answer off of that one, then another timeout, it'll go to the third one. So you could end up experiencing what seems to be a very slow internet experience with DNS if your DHCP v4, for example, DNS server was turned off, or at least the DNS server that was signaled by DHCP v4. So the way the IETF wants to solve this is with a thing called coming up with called provisioning domains. And there's an RFC there to help you fall asleep at night that talks about what they're doing, but it's still a work in progress, and they haven't, in my opinion, fully solved the DNS issue. But they are trying to get there with provisioning domains. All right, I got some questions for you guys. So this is where having TCP dump comes in handy. Or sorry, not TPC, Wireshark comes in handy, because I want you to download these two PCAP files, and then I want you to answer these questions, and I'll give you, I don't know, 5-10 minutes to do that, but you'll need to download them and then open them in Wireshark, and I'll do the same so that when we're ready to talk, we can cover this. So I want you to, well, first one, you don't need Wireshark. I want you to look at your resolve.conf file if you're using Linux. If you're using systemd, there is a system resolve -- status command that you can run. If you're on Windows, you can say ipconfig and see what is the IP address of the DNS server that your host that you're on right now, your laptop or whatever you're using, is what is that IP address? And are any v6 addresses in that list of, if you have more than one, are they in there? And then look with Wireshark at the two PCAP files and look for the DNS option, the v4 DNS option and the v6 DNS option, and see if you can find what those addresses are that are given. Any questions about that lab exercise? Okay, go to it.
All right, everybody, let's cheat.
I don't think there's a lot of cheating. I didn't give the answers. And hopefully I got the links right. I'll go download them and anyone not understand the lab or what we need to do?
Yeah, I'm kind of lost on downloading those files. Just not sure where we're getting them from. Maybe I came in late and I missed something.
So do you see the hands-on in the presentation?
Yes.
Okay, so you need to see this presentation on your machine, and I've pasted the URL into the chat.
Okay.
And then
There you go.
there'll be little blue things you can click on, and on my machine, it just fires up Wireshark and loads those files.
Okay, super. Thank you.
You're welcome. Anyone else having problems with that?
I had the same problem, but I will follow the same solution.
Okay, sorry, I should have mentioned that more clearly.
No, I also was running a few moments late, so I must have missed it on the beginning. All good.
Okay, no worries. We try and make these Netsigs as interactive as we can, but since it's all virtual, it gets a little bit more fun.
If you're doing this on a Mac, it gave me the choice of downloading the thing or opening it with Wireshark. And so I started out downloading it, and then I spent the next 2 or 3 minutes trying to figure out where the hell it stuffed it.
Which is why I just said, yeah, go ahead and open it with Wireshark.
Exactly. So I surrendered to that. I'll find it later.
It's probably in your downloads somewhere.
Not even that. No, that was the obvious place to look. Anyway, Wireshark's running, so I'll carry on seeing if I can do something useful.
Okay.
Oh no, Wireshark's telling me I have to reboot my Windows system. Oh, that's a horrible thing to do to somebody.
So why are you using Windows?
Because the recording software is on my Linux machine.
Oh, I see.
However, opening the captures does not require a reboot. What's the shell called in Windows?
Command, CMD.
Oh yeah, right. Duh.
Well, there's PowerShell, but I assume you're not looking for that.
In a while. Ooh, look at all those DNS servers. I got 4.
Ooh, I didn't ask who has the most.
No IPv6. Does Wireshark open more than one file at a time?
Not sure.
Oh, yes, it does. Look at that. At least this one does.
You got a tab view?
No, it's opening up different windows.
Oh yeah, that's what happened for me too.
So that V6 DNS server looks like a Diedrich server.
Say what?
Looks like it's got your prefix.
Which one are you referring to? The RA one or the DHCP v6 one?
The one from RARDNSS PCAP. Oh, no, wait, sorry. Humha. Hummaha.
That's the RA.
Yeah.
Yeah, I don't think that's Diedrich's, but I could be wrong.
Oh, it's probably not. It just looks similar.
All right, I don't have that one open yet. I'm still got my Wireshark on the other one. Anyone having problems with finding the info in the lab?
I got it. I just don't understand it, but that's okay.
Well, we're going to talk about it.
Good. I'm just going to get another scotch then.
Okay.
It's not going to help.
That helps with comprehension.
Yeah, it definitely helps comprehension.
It helps immensely. Or not caring.
Shane, are you finding everything okay? You just shake your head yes or no.
I ran ipconfig/all, and it shows me a bunch of information. Was it supposed to also create a file?
No, it doesn't create a file. It just shows you a bunch of information. Some of that information should be about DNS.
Okay. In that case, I don't have the result.conf.
Yeah, Windows doesn't have that. That's why I have in the notes to you have a Windows machine to use the ipconfig/all.
Yeah, a note to Shane, there might be a lot of different adapters on your system, so it might have flown up the scroll screen. So maybe use your scroll bar to look back and forth through it.
All right, we'll wait for Scotchman to come back, and then we'll start talking about some of these items. Sounds like Deed.
Oh, what? Where?
Okay.
You
We're
weren't
waiting
waiting for me, were you?
Yeah, waiting for you to get back.
I
Okay.
didn't-
That's fine. All right, so let's talk about the first bullet. If you are running a Linux system, your resolve.conf. If you're running the systemd, the other one, or the Windows. So how many addresses did you see, Shane, in your DNS portion?
You mean what shows in Wireshark? I've got 12 there.
No, I'm just talking about your ipconfig/all.
Oh, sorry,
many?
there's 2 pages of adapters.
Okay.
Can
Unfortunately,
you-
I don't have a Windows system, so I can't. I can't tell you. There should be a DNS section on the left-hand side, and there'll be IP addresses on the right-hand side.
The heading is called DNS servers, and it's near the bottom of an adapter entry. I have 2 adapter entries, and one of them has the DNS servers for the internet. The other ones don't.
Okay.
So do you see that, Shane?
I'm going to dump it into a file and then search the file and see if it'll
Okay.
because there's too much to
You
read.
got a lot of adapters. Okay. I'll ask Mark while you're looking at that. Mark, did you find your DNS servers?
I have 4 of them.
No, sorry, the other Mark.
Oh, the other Mark, sorry.
Yeah, as far as I can tell, I only have one, although, so I'm on a Mac. I have a slightly different IP address, whether I look in Wireshark or I look on the Mac's Wi-Fi config.
Okay. All right. So for the first question, we're not looking at Wireshark yet. We'll come to that.
Okay,
But so you got one.
I got one.
Okay, good. And Mark number 2 or Mark 0, depending on how we count you.
Call me Marky.
Marquee, or we could call you Mark G. Okay.
Call me that.
How many do you have, Mark G?
I have 4.
4. Oh, you're somebody.
Yeah.
Deed, what do you got?
Best I can figure 1, but ifconfig on my Mac doesn't play nice, so I haven't figured out what the question is. All right.
Yeah. If config won't show you that, you have to look at your resolve.conf.
Yeah, and resolve.conf only has 1 entry, which points at the router.
Okay. Okay. Greg, how you doing?
I'm okay.
How many you got?
I only have 1. I'm actually running on a WSL box right now.
WSL. What is WSL?
Oh, Windows subsystem for Linux.
Oh, okay. Okay. Who else? Cody.
Well, I'm still trying to, when I'm on a Windows machine. So when I'm running ipconfig all, it just kind of flashes and then goes away. So I'm trying to figure out why it's doing that.
Ew, that's irritating.
Yes, very.
Okay.
Are
You could
you
read-
opening a command window first and then running the ipconfig all, or are you just running ipconfig all from the run line in the start menu?
Yeah, from the run line. So maybe if I open a command window first.
Yeah.
Yeah, open the command window first.
Okay. Thanks, Lynn.
Yep. Good thing I hadn't thought of that. Thanks, Lynn. How you doing, Lynn?
Okay, sort of. I've had some technical problems tonight. So my good Linux machine that I had set up is now decided it doesn't want to have an internet. So on Windows, there's just the one DNS server, but it's my router, and the router is going to have all the other information.
Yep.
in it.
Okay. All right. And we'll come back to Shane. Yeah. Did you find it in the file?
There's 6 addresses listed next to
Wow.
the servers.
Okay. I think you're the winner.
Well,
Okay, I'm gonna go switch to mine, which is a Mac. So I'm gonna stop sharing this thing. Oh, close to death. Stop sharing, and I'm gonna share a different. My terminal window. That's not it. Let's click on the right button. Uh,
I've got 4
oh,
DNS servers, 2 IPv6 and 2 IPv4. Does that sound normal?
yeah, could be. Could be. All right, so this is going to take me give me a second because Macs won't share on virtual screen, so I have to put a terminal in that screen. So give me a second here. All right. Allow, make that big. I don't think I can, maybe I can change this text size here. Let's see. And make it large. There we go. So if I say cat etc resolve, this is what my resolve.conf looks like. Everybody can see this? Yes or no?
Yep.
Okay. So you can see I have a search list here for my network at my house, which is called ho'omaha.net. I have 2 name servers, a v4 name server and a v6 name server. And but it won't use this v6 one until the first one fails, which happens to be my router. So if that fails, then all bets are off. Okay, let me get back over to Firefox. Let's just see if we can. No, that's not what I wanted to do. I forget how to get out of here. Yeah, exit full screen. All right, we'll just go with this. Okay, so that's sort of number 1. So I have 2. Are there v6 addresses in the output? And I think some of you said yes, and most of you said no.
I have 2.
You have 2, so you got 1 more than me. And third bullet, any questions on the first bullet? Okay, second bullet. Sorry, third bullet. Using Wireshark to look at this file, what does the DNS option look like? So let's switch over to that file, Wireshark. So this is the file. The way DHCP-v4 works is it's kind of a 4-step process. The client, which has no IP address, you can see here on the right side, the source, it uses all zeros as its source address. It uses the broadcast address, and this is what a v4 broadcast address looks like. So it broadcasts that out and hopes that there's a DHCP server out there listening. The DHCP server then makes an offer, and then the client makes a request, and then the DHCP server acknowledges that. So let's go look at the offer. And so when I go into this middle section here of DHCP, we want to be at the application layer. So let me close this. So the bottommost is sort of an inverted in Wireshark. So the bottommost thing here is the application layer, and the topmost thing is basically the lowest level. So this would be layer 1. The second one would be layer 2, or Ethernet in this case. Third layer is the IP or network layer. Fourth layer is UDP. And on top of UDP, the bootstrap protocol, which DHCP actually sort of glommed onto, is what DHCP uses. And there's a bunch of bootstrap stuff. But then here we get down to the options. And so if we look at somewhere in here, it's got all sorts of good stuff in here. Domain name server. And the domain name server it's passing out is this address right there. Did everybody find that, or did they have trouble finding that, or how did people do?
Yeah, I found it. It wasn't called Bootstrap. It was called Dynamic Host Configuration Protocol Offer.
Well, you can see it says here, the offer up here, but what I'm saying is when you look at the middle section, it'll call it Bootstrap.
Mm-hmm.
Or at least my version calls it Bootstrap.
Right. Mine calls it Dynamic Host Configuration Protocol.
You must have a newer version of Wireshark.
Likewise here.
All right, you caught me with an old version of Wireshark. Okay. All right. Any questions on this one before we move to the next PCAP?
Just had a little note that it's actually with like that. If you have teleservice, I'm pretty sure that it's probably the same with other service providers. It's actually when you send that DHCP discover, that it actually when your packet gets to the access node, it tags an option onto the DHCP packet. That's how the actual TELUS and any of your service provider knows where that packet is coming from. So that's how they actually identify you as a customer.
But what you're saying, you'll see that it's called a
it's the option is option 82 for V4, and I think it's option 18 for V6.
Yeah, I'm just trying to remember what the name is for option 82. It's a channelized or something option.
Circuit ID.
Yeah, circuit ID.
Yeah.
And you'll see that circuit ID in the response, is what you're saying.
It comes. I'm pretty sure you probably see it on the response, but it's actually tagged as on the way through on the DHCP discover and on the. I think it's all in the request as well.
But what I'm saying is you won't see that from your host.
Coming back? No, I don't. I'm not sure if you see it on the return.
You might see it on the return, but you won't see it on the outbound. Okay, fair enough. Yep, circuit ID. There might be. It's also used in enterprise networks where they have a single DHCP server serving multiple subnets. And they'll use option 82, the circuit ID, to differentiate so that they can hand out the right IP address.
Yeah, and in similar fashion, it's just a way to differentiate service. So that's actually where they figure out, okay, this is the customer and what service you have, basically. So all the rate limiters that get applied to your service, that's because of that, basically your option 82 values.
Okay, so all you got to do is hack in a different option 82 value, and
if you can get into the access node, that's where it gets inserted. So
right, it's a DHCP relay. It's where I've seen it does that in enterprise environments.
Yeah.
All right, so let me see. So let me go click on the other one and see if that will open with Wireshark, and I'll see if I get 2 files. Oh, hey, that's a pretty exciting pCapture.
One line.
Yeah. So this is a router advertisement in IPv6. The routers send out information. They send it to a multicast address, not a broadcast address, and this is the multicast address. V6 always starts with FF for multicast addresses. So if we dig down, a router advertisement is a form of ICMP in IPv6. IPv6 uses ICMP in extended ways from v4, more than just ping. And so if we dig down into this router advertisement, we'll see there's all sorts of cool information, but there's also this thing right here, which is the DNS server. And there's only one listed. Any questions about that?
Found it.
Okay. And did anyone try and do the extra credit?
Yeah, what was the extra credit again? Just a second.
Extra credit.
I did it.
Oh yeah, I did that too.
So let's go look at that one. So in IPv6 or DHCPv6, it can do the 4-way handshake very similarly to IPv4's DHCP, but there's also a short method of just doing a 2-way.
Oh.
So a request and an advertise, and you're done.
Oh.
It has to be enabled at the server to do two-way. And the idea there was a server could be heavily loaded. So we can lighten the load just by doing a two-way. So in this case, it's a two-way. There's lots of layers here. You can see we have the wire, we have Ethernet, we have PPP over Ethernet, we have PPP, which is why you have PPP over Ethernet. Finally, we get to the network protocol, which again has that multicast address, UDP, and eventually we get to DHCP-v6, which is the application. So if we dig down into that, am I looking at the advertise? Let's look at the advertise. So this is what the server is sending back. And if we click down here, here are two DHCP or DNS server IP addresses. Any questions about that?
I have a question. The source server for the second packet, number 2, FE80::200:FF::FE00:0, is that some special number, or is that just someone set that? Or is it it doesn't look like an auto configure thing.
It kind of is an auto configure thing. So an FE80 in IPv6 is a linked local address.
Yeah.
Which means it will not pass a router, which is great because you typically don't want something on the internet answering your DHCP requests. You want something on your network to answer your DHCP requests.
Yeah, got it. I just want to know the origin of that particular value of that address. Was that
And I'm getting there. I'm getting there. The MAC address of this device is all zeros because it's PPPoE. And when you convert a MAC address of all zeros to the 64-bit to an EUI 64, or the last 64 bits of a V6 address, you have to flip a bit.
Yeah.
Which is why there's a 2.
Yeah. Cool.
And everything else is zeros, and then you insert the FFFE in the middle.
Yeah. All right. I should have seen that.
So that's what's happening there. And you'll see that he's responding to the client's linked local address as well. It's all done with linked local addresses rather than 0.0.0 and 255, 255, 255.
Thank you.
Okay. No, that's a good question. You thought you were going to stump me, but I got you on that one. I think actually if I look, well, no, I can't look there. If I look in PPPoE, I don't think it's going to give me anything exciting. Yeah, it's not going to give you a MAC address. It's a faked MAC address. Is what it is. Okay. Any questions about the 3 PCAPs or anything in this lab that people have questions about? Okay.
I have a question.
Yep.
In the previous screen, it showed
This one?
what looked like a local address for the DNS server. Does that mean that the DNS server is local, like on your machine, if the address begins with 192?
Okay, so the V4 one. So let me just open that one again. Probably creating zillions of these things on my thing. So you're talking about the DNS server, so the offer.
Yeah.
And broadcast, this domain name server here. That one right there?
Yeah. So the address is 192. Does that mean that it's stored locally on your machine? Is it that it's on your machine?
It's not on this machine because this machine's address that he's going to be offered is, should have an IP address here somewhere.
Or sorry, not necessarily on the machine, but locally.
It'll be on the network.
Yeah.
Yeah, so this happens to be the router's address, because if you look further in here, it tells you what your gateway address is right here, router. So this DNS server happens to be on the router.
Oh.
Does that make sense?
Yeah, I didn't know that a router did that.
Yeah, almost every router, every home router, will include a caching DNS server. So if I don't think you were here for last month's, but you can look. I can show you how to get to that presentation. The way recursive DNS works is basically you ask the closest or whatever your configured DNS server is, and if it doesn't know, it's been configured to go look further into the internet for the answer, and then eventually get that answer and give it back to you. So your router will do that, and it will also cache that answer, so that if you are saying using a web browser and there's multiple requests for CNN.com or Twitter.com or whatever, it doesn't actually have to go look those up a second time because it's already in its cache.
Okay, I was aware of the cache. I just didn't know that there was a separate.
Yeah, most routers will also run a DNS server.
Okay.
Most home routers. Okay, that's a good question. Any other questions? Okay. So let me reconfigure my sharing. So give me a second here while I send you into Never Never Land. Is it this one? Yes. Okay, so continuing along, let's talk a little bit about the search list. So everybody can see that?
Yep.
Okay. So the search list, as I mentioned, allows you to just type in a name rather than the entire, it lets you type in the first part of the name without having to type in the whole part of the name. So for example, here, you might have things that are in your network that's called a NAS and a router, and maybe you have a music server. And if you have a search list that has an entry of example.com or whatever your home network is that you're calling it, then you only need to type in your browser music or router or NAS, and it will automatically go to that. So as I showed you in my Xterm, I have a domain name that I've registered that I only use in my house called ho'omaha.net. And so with the DNS search list, I just have to type in music or router or whatever, and it will automatically append ho'omaha.net to those URLs when it's making the request for the DNS, when it's making the DNS request for the actual IP address of whatever that machine name is. Does that make sense so far? What a DNS search list is?
Yep.
Okay.
For me.
So
Does
Yep.
more than one domain work reliably, or is that operating system dependent?
Good question. I've only done it in Linux or Unix systems, and you can use more than one domain. It may slow down your request because it actually has to go generate two requests, two FQDNs, which fully qualified domain name, to do searching. So if you had example.com and ho'omaha.net, it would actually make requests for music.ho'omaha.net, and it would make a request for music.example.com.
I wonder, and which one do you get back? And is that an interesting?
As long as you only get one back, you don't have a problem. If you have two back, then you're probably using the wrong search lists.
Yeah.
Should I go shopping? Sure. Is there anything?
It's typically where I've seen search lists used is typically in enterprise environments where, again, they have a bunch of servers that they've defined, a mail server, maybe there's a local ticket server for opening up network ticket problems and things like that. And so they'll have a search list. So when I worked at Sienna, big surprise, it was sienna.com. And so it just meant that you did a little bit less typing at your machine. You can certainly type the whole thing, but it gets rather tedious to type the whole thing every time. And then you go and find that Chrome OS doesn't actually support DNS SL. And so you end up having to type the whole thing anyway. So we have a similar problem with DNS SL. The SL is search list, not secure sockets. We have a similar problem.
Quick question.
Sorry?
Was that Chrome, the browser, or Chrome OS?
Is that true? I pretty much only run Chrome and Chrome OS. So no, the browser, it's not a function of the browser. It's a function of Chrome OS.
Okay, thank you.
So you have the same problem with DNSSL in the sense that it can come from DHCPv4, DHCPv6, or from your router advertisement. And again, which one gets preferred? If you, as a network configuring person, don't configure the same search list name in all three, you're going to get some weird problems, and people will call you up for support and say, why does it work on this machine, but it doesn't work on that machine? And you'll spend a lot of time scratching your head. So not saying you have to do it this way, but if you're configuring DHCP and DNS search lists, try and use the same thing. So the reason I'm saying the word thing is because it's not going to be the same DNS IP address for DHCPv4 and DHCPv6, but it might be the same machine that is responding to both those requests, either v4 or v6. Okay, any questions about search lists and how they help you and why they're good and save you typing unless you're using Chrome OS? Maybe even older versions of Android? All right, let's talk about captive portals. Anybody been to an airport or a coffee shop in the last year? Not going to say the last 6 months.
I have.
Okay. You might have discovered that they're using a thing called a captive portal, which means you can't go anywhere until you say you agree to their terms or something like that. And why do they run captive? That is, how do captive portals work? Anyone know?
The lawyers made them do it.
Quite possibly.
That's the reason.
So captive portals, yeah, certainly there's that aspect to it. But captive portals actually use a man-in-the-middle attack for DNS. So it doesn't matter what you type in for where you want to go, whether you want to go to Google or Gmail or Yahoo or Twitter, whatever, the DNS server, until you're authorized on the captive portal, is going to give you one answer. And that answer is their captive portal webpage. And the way they do that is they do essentially what I consider a man-in-the-middle attack. So the client here, your laptop at the airport or coffee shop, wants to make a request. So it has, say, the router as its DNS server. Well, so it makes a request to that router, and the router says, oh, wait a minute, I've got this special IP NAT table that says filter all DNS requests to my local DNS server, which then is conveniently configured to give you, regardless of what you type in for your DNS, give you one answer, one IP address back, which is their little web page. And I consider this a man-in-the-middle attack because your client thinks he's talking to the router. But in fact, what's happened is, through the magic of NAT or the evil of NAT, as some of us think, we've rewritten the packet, we've sent it over to the local DNS server. When that DNS server responds, the packet gets rewritten back such that it seems like the router replied to the client with that address. That is how you do man-in-the-middle attacks. Any questions about that? So how do you do it in IPv6? Well, in IPv6, there is no evil of NAT. There is no NAT. So what you have to do there, so these should be IP6, no, these are v4 tables, sorry, is that you will essentially block any attempt to go, so what if I just put manually my own DNS, 8.8.8.8. I'll go to Google and I'll look this stuff up. I'll get past this irritating captive portal. So what they do is they basically block it. They say, no, we're going to take everything that is going out on port 53, which is the DNS request UDP port number, and we're just going to drop it. And then what we're going to do is we're going to allow a forward over to our local DNS server. So if someone uses the router and doesn't do anything, they get their DHCP and they've got the router, we can forward it through. It's fine. That's not a problem. I didn't have to use NAT. If they try and configure their own DNS server, I'm just going to drop it, which means they're not going to go anywhere. And so that's a cleaner, simpler way of doing it. It's generally not how it's done today in captive portals, but it can be done this way. And essentially, you can do the same thing. Do I have another one? You can do the same thing for IPv6. So you can set up your IPv6 tables that block all outbound destination port 53 and allow, if you're using the router configured DNS server, in this case, this address down here, then we'll allow that port and we'll forward that to get it over to the DNS server. So we don't need NAT. Is that anyone have questions about that?
So if you're using a VPN, that wouldn't have any effect on the man-in-the-middle attack?
So if you're using a VPN, what they're going to do is they're going to block the VPN. They're going to mark your MAC address as not an authorized MAC to be forwarded to the outside world, and you won't be able to get out at all until you click their little I accept box, and you have to turn the VPN off to do that. Does that answer the question?
Yeah.
But it's a good question. Yeah, what if I have VPN? Well, that kind of goes down with here. Where we can talk about DNS over HTTPS or DOH. It has an RFC. You want to go look at it and see how it works. Why would you use DOH? Anyone have any ideas?
Doesn't it prevent your ISP from finding out where you're going and tracking?
It can, sure.
So sort of privacy and security reasons, I guess, to some.
Sure. Yeah. 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 Any other reasons why you want to use DOH?
I'll say that the HTTPS port 443 is rarely, if ever, blocked. So there's that.
Right. You may be in an enterprise environment where they're blocking outgoing, just like I showed you in the previous network diagram. They're blocking outgoing DNS requests unless you use their own DNS servers, but they're not blocking 443.
Your,
Yep.
For infosec Camosun block outgoing DNS requests, you could only use their servers. If you tried to use anything outside of that, it just didn't respond.
Right. So that's very similar to the captive portal example I gave above. So yeah, DOH allows you to sort of get around that. My concern about using DOH is, who are you putting your trust in? So earlier, I didn't catch if it was Mark or somebody who answered about the privacy. Do you consider, who do you trust more? Do you trust your ISP to track you and look at your DNS requests, or do you trust a private company such as Cloudflare or Google to track you and look at your DNS requests? Because essentially you're just moving your trust from one place to another. So there maybe you live in a country, I don't think anybody attending tonight lives in that country, but you might live in Egypt or UAE or someplace where you really don't want your ISP to be inspecting your DNS requests. And maybe DOH makes a lot of sense there. But where DOH causes a big problem is, what if you're running your own DNS server? Because you have that thing called NAS, that thing called music, that thing called router or whatever on your network, and you want to be able to get to them by name. If you enable DOH on your browser, either in Firefox or in Chrome, it will not resolve the local names, because you've essentially asked either Cloudflare or Google or someone else to resolve names for you, and it won't know anything about the names of machines at your house or your small office. So DOH causes a problem there. Or if you're at your enterprise, at your place of business, and you're trying to get to one of the local machines inside your corporation, and you've got DOH enabled, you're more than likely not going to be able to get to that machine, because you're not going to be able to resolve it, because that's an internal machine to that corporation. So DOH is not without its challenges, but what if we could have our cake and eat it too? So what if we want to run DOH and a local DNS server? How would we do that? Especially in a small office, home office environment, where you might have machines on your local network or in your house that you want to reference by name rather than by IP address. And especially if you start using V6, you will want to use it by name. How do we do that? Well, in the old days, we would have a zone file, especially with Bind 9, the Berkeley Internet name daemon. We'd have a zone file, and we'd have different names, and we'd have A records and quad A records, and maybe we even have dynamic DNS that creates these records for us automatically. Routers can do this as well. But again, if we have DOH, we're going to have a problem with how do we get around it, or how do we get access to those local DNS servers. So everybody here who's been to these Netsigs and VicPiMaker meetings before would know that I'm a big fan of open source router software called OpenWRT. And open source router software is OpenWRT is pretty cool. It runs on about 1,000 different home routers. It doesn't run on every one of them, but there's a big long list. But one of the things it can do is it can, through the magic or through the power of recursive DNS, it can be your DOH proxy, if you will. So the client thinks it's just talking to the router. The router, instead of the next hop of the router for DNS sake being your ISP, which is under normal configuration, that's what it would be, the router instead can set up its own DOH service to Cloudflare or Google or whoever you've designated and make DNS requests to that service. So we get the best of both worlds because we can run our own DNS server here on the OpenWRT router with our local names, and it will resolve those because it's just a straight DNS request. But if it's not a local name, if it's twitter.com or whatever, that request will go through a DOH tunnel to, in this example, Cloudflare, which will resolve it through the recursive DNS mechanism that was described last month. Get an answer, reply back through the DOH tunnel, back to the DNS server on your router, back to your client, and you will have accomplished the privacy aspect of DOH and be able to resolve your own names within your small office home office. Any questions on that? Good. So,
Actually, Greg, I do have a question.
Sure.
And you probably explained it. My mind.
Sorry, did I lose you?
Sorry, I stopped pushing the button.
No.
My mind was off wondering about making a Cat5 cable. So,
Okay.
To implement some of this stuff with the router, and anyway, how does it differentiate between I type a local name versus one out on the inter thingy?
So the local name will be in the router. So you will either set up a domain name within the router, like I have. My example is hoomaha.net. So if I go to printer, actually my printer has got a Hawaiian name, but we'll just call it printer.hoomaha.net, then I will be connecting to my printer, versus if I go to a domain name that's not, that the router is not an authoritative server for, it will then punt that request upstream through the DOH tunnel. So it has to do with the fully qualified domain name.
Okay, so the bottom line is if the router doesn't know how to deal with it, it will punt it. That's the short answer?
Sure. We'll go with that.
I'm good with that.
Okay.
Until I actually want to implement it, then I may want more detail.
Okay, sounds good. All right. But that was a good question. How does it know how to answer? Well, it's either the authoritative DNS server for your local network, or the request is for some other machine that it is not an authoritative server for. Okay, any other questions on OpenWRT and DOH? And you can have your cake and eat it too.
As long as you don't blow out the candles, I'll eat the cake.
Okay, sounds good.
Can you set up OpenWRT to round robin through a bunch of different DOH servers over, say, a period of an hour?
To be honest, I don't know, because I've only looked and saw that there was a DOH package, and I've seen chatter that you can configure it to do DOH. I have not set that up.
Yeah, just sort of a way to mitigate sending all your DNS to one of these free providers, sort of cycle through them.
That would be a nice feature request. I'm not sure they do that because, as I said, DNS as a whole doesn't do round robin. And by default, DNS uses the first one and stays with the first one until it gets timeouts for non-response, and then it goes to the second one. DNS does not do round robin as a general rule.
So yeah, so the OpenWRT DH server software, you'd have to custom write that to do that sort of thing, I guess.
Yeah, you'd probably have to tweak it a bit, but it's open source, and after you write that, you can commit it upstream and put a little checkbox in the configuration file and say do round robin.
Excellent.
All right, so I've got some more questions for you. A second lab. I want you to fire up Wireshark on your machine and start sniffing the interface that you're attached to the network on, to the internet on. And for those of you like the other Mark that have lots of interfaces, you're going to have to figure out which one you're making your requests on. Because pretty much I'm betting it's going to be one interface. The others might be virtual interfaces for virtual machines and things like that. You don't want to sniff on those interfaces. Okay, once you get that going, then I want you to open up a browser or use wget, really doesn't matter, and make a request to neverssl.com. And the reason I picked neverssl.com is probably because you guys haven't been there, so it's not going to be in your cache. So since it's not, because browsers also cache DNS. So go there and then answer these questions. Like, what's the IP address of your DNS server? We're going to look at that capture after you've made the request to neverssl.com. And we're going to examine that capture. We're going to look at answer these questions. Is it a V4? Is it V6? What port is DNS using for its replies? Is it THCP, UDP? Okay, so I'll give you about 5 minutes to do that. And I will go fire up my Wireshark and do the same thing.
That's going to be pretty tricky with all that network traffic flying by.
Well, I'm going to show you how to narrow that down a bit. Wireshark is pretty cool for doing that kind of stuff.
Never SSL, eh? Okay. Let's give that a try.
Want to quit this.
Oh, there it is. Look at that. Hmm.
Yeah. Yep, I see my first problem is I have to get Wireshark working in sudo mode.
Is this a trick? There's no V6 address for it.
For sudo mode?
No, for neverssl.com.
I think there is.
Well,
I've seen it respond on V6.
it asked for one. neverssl.com, and the response.
Okay, don't give it all away. Don't give it all away.
Okay, I'm just thinking out loud.
Yeah. Well, mute your mic while you think out loud.
How do I get Wireshark to start showing traffic?
So what operating system are you using?
Windows.
You need to get it to attach to one of your interfaces. And at the moment, I'm trying to get that to work in Mac OS X.
I had a list of all the interfaces on my start page of Wireshark on Windows.
Yeah.
And I had to find the one that said Ethernet, basically the one that had the DNS servers. And it was just called simply Ethernet. And I don't know if yours is going to be the same or not. But I also had like 5 other interfaces that I had to look at and go, eh?
Does that help?
And then I click the little shark triangle menu item at the top left to start capturing.
And then once you get the Never SSL page, hit the red rectangle to stop. Otherwise, it'll get really big.
My never SSL doesn't do anything because no script says no.
Okay, anyone else getting or not getting Wireshark to work?
I'm looking at network traffic, but in the last few seconds, there's been over 30,000 lines of.
Right, because we're busy doing video as well, so that's going to trash up the capture a bit. But that's why I say start it, go into your browser, type neverssl.com, press return, see something pop up into that screen, and then go stop the Wireshark. Otherwise, yes, you'll end up with hundreds of thousands of packets.
That's fairly impractical. So, Craig, I put in a UDP port equals 53.
Hey, don't give it away.
Well, you're not going to be able to capture that with.
I captured mine.
The Jitsi traffic is just overwhelming.
Jitsi traffic is got some stuff there. I agree, but this is how we learn, people. Yes, there are easier ways, but you got to learn the hard way first. Okay, let's take a look at it. So the first question is the IP address of your DNS server. So let me share to back to my Wireshark. Let me share my Wireshark screen. Let's try this one. Yeah, that's right. Okay, so this is my Wireshark screen, and I've got, if I come over here, I've got 4,000. By the time I turned it off, I had 6,000 packets, which in a busy network is what you're going to have to look at while you're trying to troubleshoot this. But the beauty of Wireshark is that it has these display filters. And if you remember me mentioning earlier that DNS comes over UDP, so you say UDP port equals 53, then it will only show me DNS requests. And suddenly my 6,000 packets come down to a small little handful. So trying to answer the first question, what is the IP address of your DNS server? Well, in mine, it's 10.1.1.1. Anybody have trouble typing in the little display filter and seeing the DNS request out of that big pile of packets?
Craig, what's the syntax for putting that in? Because I put UDP. Oh, never mind. UDP.port equals 53. There we go. Thank you.
You're welcome. And if you get it right, it'll turn it green. If you get it wrong, you'll see a red thing, which means Wireshark doesn't understand that. Okay, so let's just do a quick round robin, I guess. Who hasn't seen the initial request for the DHCP, or sorry, for the DNS in their Wireshark?
I'm not getting anything referring to never SSL once I use UDP IP port equals 53.
So you don't have any packets displayed.
I've got some Twitter, a couple of Twitter packets, and some gstatic.com, a couple of those, and that's it. Just 4 packets.
Okay, maybe that's okay. We can work with the Twitter ones. What is the IP address of the DNS server that the request is going to? So in
so
mine,
the
I'll put the
query,
point right here, the destination address of the request.
I'm just gonna, the destination address of the standard query is, it's not IPv4, it's IPv6.
That's okay. I speak IPv6.
Okay, 2001:568:FF09:10A:53.
Very good. Okay. So you're using v6 for your server, and you did a record for Twitter, and it must have given you a v4 address back. Like this one right here. Here is a record response.
I get a record response.
And if you look into that a record response, as I'm doing here with the Never SSL, then we go into the answers. You'll see here that there are 4 A records associated with this server, and with Twitter, you might have more. You see that, Cody?
I see answered. Okay, answers. It says answers RR:0. So maybe I'm not looking at the right thing here. Let me try this one.
Yeah, or maybe it's not responding. Maybe you didn't get an A record response. I don't know.
Mm-hmm.
Could be for some reason. I don't know why you wouldn't get a record response.
Yeah, let me try this whole thing again. Move on to somebody else. I'll try again.
Yeah, because here I can see the answers as RRs equals 4, so I got 4 of them there.
Yeah, well, I just get answer RRs=0.
Yeah, which means you didn't get a response.
No.
Okay, who else? Anyone else see their query and see the IP address that they're going to, which is the destination IP address, which probably is your router?
I do.
Okay, why don't you tell us yours, Mark G?
Mine's a v4. It's 216.232.132.61.
Ooh, that sounds like a real routable IP address.
Tis.
And when you look at the response, the A record response, do you see 4 addresses, 9986 addresses?
I see. Where's my answers? I see 1, 2, 3, 4. 4. 99.86.33. So on.
Okay. All right, I'm going to pick on somebody else. About Shane, did you see any Never SSL DNS requests?
I've got about 5 pages, and I'm going through the info lines, and I haven't found Never SSL yet. Is it possible to add criteria to search the info column?
No, I don't think so, because the info column is sort of a synthesized column by Wireshark itself.
Okay, so it might be there. I just haven't seen it yet.
Okay, but so you do see a record request though, right? Like my top line here, where it's making a standard query for an A record and somebody else's name here at the very end of the info.
I believe so. Yeah, I've got standard query and then an address. Okay, yeah, I got those.
Okay, so if we look at the destination address, or I think you can see my mouse. If you look at the destination address of that line, it's got an IP address in it, right?
Yeah.
And what is that IP address?
It's exactly the same as the lady, I'm sorry, I forget your name.
Cody. So it's a 2001 address.
I don't think her name is Cody, but it's V6, beginning with 2001.
Okay.
Do you want the rest?
No, that's fine. That's fine. And if you look at the response, whatever that domain name is, if you look at the response to that, so here on mine, it's 2 packets down to here, you should see some A records in the answer section. Do you see that?
Yes, so I've got response A, and then a Google URL A followed by version 4 address.
Okay. All right. Lynn, I haven't been picking on you. How's things? Lynn still with us?
Yeah, I'm still here. Yeah, I've got some Never SSL stuff in the in Wireshark. The source IP is my router 192.168.0.1, and in the info standard query response neverssl.com, and that says 99.86.33.21 and a bunch of other 99.
Bunch of others. Okay. All right. And anybody see the quad A request? So notice that this, in my capture, that my client has made a request for an A record, and then in another packet, it makes a request for the quad A record, which is the V4 address. And so there should be a response then. So if I click down a little bit further here, you'll see here is the quad A response, sort of the IPv6 address response to that second packet in my capture. And if I look down here, where's my answers? I got 0 answers. And yet, if I do a query to here and look at its response, I do see lots of V6 addresses.
I'm seeing the same thing, Craig. I see the V4 request, or the V4 request and the V6 request, and I see answers to both. And looks like the same answers. I didn't memorize them.
Yeah, okay. It probably is. And so the question I have is, how did it know to go there? It must have made a request to this guy here, NS 1716 AWS DNS, so forth, which then meant that it would go off and make queries to that thing. And then get the response. That's my guess. I could be wrong. But it clearly has gone through sort of 2 iterations to get to the V6 addresses. Okay, so back to the line of questions. So we figured out what the router was, or, well, the initial DNS request went to by looking at the destination address of the query. We looked at whether it was V4 or V6. Or I guess I can switch back to, let me switch my, yeah, too many windows open. Let me switch back to my presentation, which I think is this one. Yes. To answer the questions. So we figured out whether it was going to a V4 and V6. Some of you guys were seeing your DNS request going to a V6 address. A lot of people were seeing it going to V4 addresses. That's fine. The joy of DNS is that it doesn't really matter whether it's the transport is V4 or V6, just as long as you get an answer back. What port number is the DNS requests going to? Anybody know that one?
UDP 53.
Right. And you also answered the second part. It's UDP over port 53, not TCP. DNS can use TCP, but most often it's not configured. And the reason that is because if a DNS server gets heavily loaded, it'll stop answering certain requests. It'll just say, I'm not answering that one. And it will expect, by using UDP, it doesn't have to maintain a bunch of buffers, and it can easily just drop that packet and move on to answering other requests. And then it's up to the client to figure out, oh, I didn't get an answer. Should I try again? Oh, okay, let me send another UDP packet. And it will do that for a few times before it finally gives up and goes to whoever is second on your list of DNS resolvers. And that's why DNS usually uses UDP. Doesn't have to, always, but it mostly does. All right, any questions about the Lab 2?
Just to confirm, if this was cached in the browser, the results wouldn't show up in Wireshark?
That's correct. Because it won't bother making a request. The browser will say, I've got that address already. I'm just going to use it until I can't get to it anymore, and then maybe I need to, or maybe the TTL is expired in the cache, and then I'll request it.
Okay, I think that's the problem what I have, because I did things in the wrong order.
Yeah, no worries. That's all how we learn. By the way, Never SSL is a great URL to remember and maybe even bookmark if you are traveling and you are using a captive portal. You may have discovered that you have a hard time navigating your way out of the captive portal, at least with a laptop. Most phones have figured out how to do this, but the reason is because there's a rule. If you have an SSL connection to a particular website and you press refresh, it doesn't. The rule says you can't go from a secure connection to an unsecure connection, which most captive portals are. Which means your laptop is busy trying to reload this SSL connection and it can't because you're not authorized and you're not even getting to the captive portal webpage. So if you use Never SSL by its very name will never be SSL or TLS protected, which means that it can be redirected to your captive portal by just typing in neverssl.com, and your captive portal will work. So that's why I use Never SSL.
Sounds very handy. Thanks. Good tip.
You're welcome. All right, so DNS.
Question, Craig.
Yep.
In most of the examples you showed, and most of the stuff that I saw as well, the DNS provider or server was in fact my router. And that's the only DNS server I've got is my router in most cases. So you suggested in one of your comments about a minute or so ago that if it times out or gives up and you've tried so many times, and then you're going to go to your second DNS server to try and find it because the first one failed, but I only have one. But I'm assuming my router has probably a couple or three.
Nope.
Because that's what it got when it connected to SHA or whatever.
Oh, yes, it might. But if it is not responding to you, if the DNS server is not working on your router, like if you go into your OpenWRT router and you go kill DNS mask, which is the name of the application that's running on your OpenWRT router that provides DNS, then you will think that the internet is down because you won't be able to resolve any names because you don't have a second DNS server on your host, on your laptop. Does that make sense?
It does. That makes sense, but I don't think it answered the question.
Okay.
I'm assuming that SHA is going to give me, in my case, a couple of DNS servers.
Yep.
And that my Open WRT router is going to ask for SHA to give me an IP, and it will try both of them.
It will try one until the first one fails, and then it'll try the second one in the list.
So I'm going to, to me, this is all transparent. If
Yes.
it fails, then nothing is going to get me any solution other than the fact that I could change my DNS to something else, like the DNS server I'm running on one of the other machines I've got at home.
Right, but what I'm saying is that if one of Shaw's DNS servers goes down, and it happens to be the first one in your router's list, then your router will try until it gives up on that one, and then it'll go to the second Shaw router that's DNS server that's in your list. And then things will work just fine again. And it required no intervention on your part because, as I said at the beginning of the presentation, DNS is designed to be fault tolerant and resilient. Does that answer the question?
That one did, yes.
Okay. Yeah, the router's caching DNS server on the back end, on the WAN side, looks just like a DNS client to the ISP. So it's definitely a client server situation. Okay. Any other questions? That was a good question. Any other questions?
I have a question. So most likely the DNS was just specified by the ISP then?
So if you don't do anything and you just plugged in your little home router to your ISP and didn't make any specific changes, then more than likely the router is pointing to your ISP's DNS servers.
Okay.
By default.
Yeah, I'm on Shaw and I'm getting 2 DNS server IPs automatically.
Yep, that's very normal. Okay, so let me go to conclusion because we're a little bit over time. So DNS is an abstraction layer. It's a really handy abstraction layer. We don't really think of it as that, but it is. It's an abstraction layer that abstracts away IP addresses so that we don't have to think about IP addresses. And it's allowed, since the early 80s, it's allowed the internet to grow and expand certainly beyond any number of IP addresses I can remember, and including V6 addresses. So it's really made the internet easy to use, and we need to, as sort of network operators, understand a little bit about how DNS works and understand how do our clients or our hosts, our laptops, our machines that are on our network, how do they get DNS? Am I configuring them on my router so that they're consistent, so that I don't put in 2 different DNS servers and one's got a set of information and the other DNS server has a different set of information? Because that would be really bad, because sometimes you would connect to this IP address on server A and sometimes you try and connect to a different IP address on server B, and that machine may not even be around anymore because it was some old data that you never updated in your second DNS server. So you want to keep sort of the worldview of your DNS consistent across your devices. All right, that's what I have. Any final sort of questions or comments or?
I have 2 questions.
Sure.
Okay, so first, the Canadian Internet Registration Authority now has a DNS server which you can use, and they're promoting it as something which is purely Canadian. Do you have an opinion on whether or not it's worth to switch DNS servers from the one provided by your ISP to Sura?
I probably got that Sura email since I have a .ca, and I don't think I read it closely enough. Are they supporting DOH, or are they just saying point your IP address to CIRA?
I believe they do say, but I don't remember what.
Okay. Yeah, like I said, DOH has some problems, especially if you're going to run your own DNS. But if you have something like OpenWRT, you can run them both, and that's a good thing. I understand about CIRA. There are a lot of privacy issues on the internet that we generally don't stop to think about. Like a lot of servers are hosted in the United States. They have different privacy rules. So if you're connected to a server in Canada, like the CIRA server, then a majority of your requests will stay inside Canada. So if that's a concern to you, that's probably a good thing to do. But the reality is, if you're going to Google or Twitter or whatever, the CIRA is still going to go to the root servers, and eventually the request will be made off to the United States. So it's not like you're going to avoid that entirely, because Canada cannot operate on their own without the rest of the internet.
There's a specific type of legislation, and I don't remember the details, but it says that the data needs to reside in Canada. And I was just wondering if having a DNS server, which is also located in Canada, would be of any benefit, because even if data is located in Canada, it could travel to the US on its way to you and whatnot. It's kind of an obscure question, but
no, it's not. It's a reasonable question. Yes, I know that server data server data meaning sort of web server data for government, for provincial governments and the federal government of Canada need to reside inside Canada, which is one of the reasons why I complained to my member of parliament when I discovered that Canada.com is actually pointing to Akamai. But I'm assured that it's okay.
So my second question is, I've been having a lot of trouble trying to block cookies where I don't want a third party collecting data. And so I thought maybe I could use the host file on my local machine to change a DNS setting so that it doesn't go anywhere. Does that sound like the best solution, or? Yeah,
there's a couple of projects already that exist for that. One is Pi-hole, and the VicPiMakers, if you go to VicPiMakers.ca website, has that presentation online. I also did a presentation earlier this year, I think it was in January, about using OpenWRT and a package on that that's called, what is that package called? AdBlock. So that it basically works like a Pi-hole, except for you don't need a Raspberry Pi. You just run it on your OpenWRT router. That's designed to block ads. It's not designed to block cookies. So,
if I may, a lot of ad domains are pretty much cookies.
True, but if you really want to see what kind of cookie action you're doing, I recommend installing a browser plugin called UMatrix. And it's something I started using, and it's kind of like no script, but it actually goes much broader and also can block cookies and frames and cross-site stuff. It's very enlightening to see how much there's it takes a takes a village to raise a kid kind of thing. It takes a village to render a web page apparently these days, and UMatrix will tell you, will show you just how many other places that particular page is requesting, including cookies.
I don't think it's a village anymore. I think it's probably a medium-sized city.
Shane,
fair enough.
Yep.
One other point to make about the Windows system is sort of not really honoring the etc hosts file much anymore. So you got to be careful relying on that. Unix systems still do, Macs usually still do, but the Windows system's honoring of the hosts. Like if you try and put the telemetry addresses of Microsoft in the host file to block that, it will ignore them. So it's kind of selective in its hosts file use. these days with Microsoft.
Yeah, so you'd be better off with, like I said, Pi-hole, or if you're running an OpenWRT router, run AdBlock, and then you can put whitelists in or blacklist in either of those two pieces of software, and do specific blocking if you want to do, in addition to the adware block list.
On my machine, it respects the host file, but I originally thought that it didn't. But the problem was that if you like put in a domain like Microsoft.com, then that doesn't apply to a subdomain like technet.microsoft.com. That would pass through because you got to be more specific in specifying like each subdomain.
Right.
Yeah, you have to be host, fully qualified host.
Fully qualified domain
No,
name.
no,
Yeah.
wild
There's no
card.
wild carding. Yep. And then after all that, then you'll go and figure out that Chrome, I believe it's Chrome on Windows and Mac as well, is using Quick, and they're doing their own DNS requests directly to Google within the Quick tunnel. So, so have fun with that.
What's Quick?
Quick is a protocol invented by Google to use to do web requests over UDP, and they think it's faster. Well, it probably is faster because it doesn't have to do the TCP handshake, and it's encrypted with TLS, and you can just go do a search for Google and Quick, QUIC, I believe is how it's spelled, and you'll get lots of information. And if you sniff your wire while you're doing Google Chrome, you'll see all these UDP packets flying by that are kind of garbage because they're encrypted. It's because of Quick. But don't do it while you're using Jitsi, because Jitsi is also doing UDP packets right now. Okay, great. So next month, we don't think we have a particular topic. Is Greg still around?
I'm here.
All right, so I'm looking at the list that you gave me a long time ago.
Okay.
Does anybody have any thoughts for a network-oriented presentation next month that they'd like to see? Okay.
Give
Greg, why
me a
don't you?
while to think about that, Craig. I may come back to you in a day or two.
Okay, yeah, come back in a day or two. Greg, I would say initially, why don't we look at either Happy Eyeballs or curl, because I think that's pretty easy and straightforward. But if people have
Curl
an
is a
idea,
good one.
yeah, okay,
Sorry, what was that, Dee?
Curl is a good one.
Okay. Yeah, there's it's funny because I just did a little thing with one of my colleagues, and we did a review of curl versus this other Python command line tool called HTTPy. And curl's pretty good because it's fairly widely distributed, but we found HTTPy actually was a lot easier for doing JSON. If you have to do like throw stuff against the JSON API, it's way easier to use this other tool. So I don't know if that interests people, but I can certainly throw out some slides on that if people are interested.
okay, yeah, that's good. And also, there is you can redirect the output of curl to a JSON interpreter as well. So you can do that. You probably do a similar equivalent by using a pipe.
Oh yeah. It's more the actually passing to a post. If you have to pass that JSON document and all the quote escaping that you have to do, that gets really, I don't know. I just feel like running away and finding Python or something. But it's if you just must use it on the command line, my recommendation is maybe consider this HTTPy. But maybe I can express that in a couple of slides. Yeah,
that'd be great. Okay, so why don't we? Well, unless people come up with another idea, and just post it to the meetup or send me an email, and we'll for the moment we'll look at do's and curl and alternatives for September, and that'll be the last. Let me just call up my calendar. I got it right here. So it'd be the last Thursday, which would be the 24th. So next meeting will be September 24th.